So for your general solutions, those are your 4 types. We have 4 types, right? Type 1, type 2, and type 3, right? And then type 4. Type 5, how will type 5 be looking like, right? Type 5 general solutions question will be involving special angles, right? Involving special angles. Then apart from all of these, we have to also talk about when trig identities are invalid, but we would start here first and then proceed to the next ones. Okay, so I hope I'm very much audible. So we have 4 types, or rather 5 types for your general solution questions. I can say the main idea is to ensure that you have a ratio, right? Let me write it here. The main idea is to have a ratio equals to a number. That is the main idea about general solution, is to have a ratio is equals to a number. By ratio, what do I mean? I mean that either have sine of an angle, or have cos of an angle, right? And then or have a tangent of an angle, right, is equal to a number. That is the whole idea. So now then what's next is what we're then going to discuss. Let's start very simple, then we'll proceed to those nice questions. Let's say they say determine the general solution. Determine the general solution of the following. Number 1, I usually like to give them names, so we call this G1, right? So for G1, right, we're going to say suppose that you have sine x is equal to 0,5. Sine x is equal to 0,5. How do you solve it, right? The general procedure, if you were in grade 10, right? In fact, I'm not even going to talk about the grade 10 part of things to avoid us actually doing that. You see, let's talk about what we need to know. Whenever you have a ratio is equal to a number, just as in this case, the procedure is as following, right? You find number 1, you make sure that yes, you isolate the ratio, right? Then number 2, you find the reference angle. Find the reference angle by using arc, sine, arc, tan, you see, meaning that by using arc, sine, some people call it inverse, is fine, arc, cos, and arc, tan, right? Then after finding your reference angle, you make a cross, right? You make a cross like this, and then on that cross you must identify the quadrants on that cross. You must identify the correct quadrants. Identify the correct quadrants. Then from there you are done. You then solve for the general solution. You solve for the general solution. So it's only 4 crucial steps that we need to follow every time, which I think if you can just memorize this and do a lot of more questions, you are able to remember this. Okay, isolate the ratio, reference angle, cross, meaning identify the quadrants, and then solve for the general solution. Solve for the general solution. Let's just take note. So I'll say here, nota bene, NB, right? Let's take note that for sine of an angle and cosine of an angle, we are going to use, for these two, we are going to use 360 degrees times k. However, for tan of an angle, we use 180 degrees times k. Right, so let's just take notes there of what we use. Tan of an angle, and then for sine of an angle we use 360 times k. So let's get straight into solving this one. Now that the ratio is isolated, and make sure that here it's not negative, you must make sure that it's always positive. Your ratio is positive, right? So let me write here to say it must be a positive ratio, right? Then you can find the reference angle. That is the next step. So you simply say reference angle is equal to arc sine 0,5. Then what would be your reference angle? I need someone to assist maybe me with the calculations part, right, so that we can move faster. If there's someone who has this, can you give me the answer, please? Inverse of sine 0,5. 30 degrees.
Yes, sir.
Thank you so much, ma'am. So now that we have found our reference angle, we go to the cross. So we're simply going to bend the cross. These are all the steps which you should. If you can follow these steps, you're good, right? So I don't just draw the cross. Now I have to identify the correct quadrants. But what will assist me to identify the correct quadrants? It is the sign. It is the sign of the ratio, or the sign of the number, right? Sign of the number. Remember, we're saying general solution is a ratio is equal to a number. The sign of this number, the sign of this number will tell you the quadrants. And you look at the step just before you found the reference angle. Then you look at the sign of that number. The number there is positive 0,5. So we can safely say that the sign here is positive. So then we ask ourselves to say, where is sine theta or sine x positive? If we can remember, that is in quadrant number 1, and then also in quadrant number 2. What are we using to identify the quadrants? Remember, we are using SOHCAHTOA. So this cross, we'll make a cross, but let's remember what you call our cast diagram. Let's remember our cast diagram. Good. So our cast diagram is ASTC, right? So this cross also should remind you of the cast diagram. Now that you have this, right, please listen carefully, guys. When I say to you, whatever you have as the angle, I like to write sine of an angle, cos of an angle. I don't like to write sine theta and the likes, because I want you to understand that inside the brackets we have the angle. So whatever is that angle is the one that you're going to say is equal to. So meaning whatever is the angle here, you would put it here. Then you would say that x is equal to, in quadrant 1, let's remember that in quadrant 1 is just theta, right? So it's just the reference angle. Then you say plus 360 degrees times k. Why 360 degrees times k? Because it is sine of an angle, right? So you then say the reference angle is 30 degrees. So you have 30 degrees plus 360 degrees times k. Perfect. Then quadrant 2, you're gonna say x is equal to, right? You still take this, then is the one you write here. Then you say in quadrant 2 it's 180 degrees minus theta, right? So you take it as the reference angle, and then you say plus 360 degrees times k. In that way you would have 180 degrees minus the reference angle, which is 30 degrees, plus 360 degrees times k. So therefore your x will be 150 degrees plus 360 degrees times k, where then you don't forget just to indicate that k would be an element of integers. It's a very weird looking z, so please bear with me. to be something like this. Then you put it in brackets. So this is what you do when they say find the general solution. Actually, these sine, cosine, and the likes, finding the general solution, there are actually formulas you can use to just get the general solution using one step. But to get your marks, I would advise that we do that. So I hope we are good here. If you have any question, please do ask. If I can recap, we isolate the ratio. This one was already isolated because it was sine of an angle, and then you find the reference angle using arc sine, and make sure that when you say arc sine in here, we always put positive numbers, never a negative number. Let me write it here. So always put positive number, the number is positive. Don't put, even if here it was negative, you wouldn't put it here as negative 0.5, you will put it as positive. Let's understand that. And the sign for here tells us of the quadrants. I'm gonna try and go with this on the next page so that we are using it all the way. Right. Next, let's say you are given cos minus 3x is equal to negative 0.5. Negative 0.5. So how would we solve this, right? Well, the first thing is to isolate the ratio. Already the ratio here is isolated because it's only cos, and it's already positive, so we are good to go, right? Please don't make this mistake of dividing by -3 both sides. That is a very, very huge mistake. We do not divide by the angle, like whatever is attached to the angle inside the brackets, we do not divide. Some people go to the extent of writing this, and then this side they put plus 3x. They're like, this goes to the other side. That is totally wrong, guys. Let's not do that. The angle, leave it alone. Okay, so what do we do? First of all, we need to, now that it's isolated, right, we need to find the reference angle. So to find the reference angle, you will say cos inverse, right, or cos, right? Then you're going to put 0.5. You don't put negative 0.5, you put 0.5. Then on your calculator, what does that give you?
60.
60. Thank you so much. It gives you 60 degrees. Then now that you have your reference angle, remember we go to the cross, right? So immediately would have your cross there. Then what do? We then say to find the quadrants, where is cos negative? Remember, you look at the sign of the number, right? It's negative, so you say where is cos negative according to the cos diagram. Cos is negative in this quadrant and that one, isn't it? So it means that you know that it is in quadrant 2 and then in quadrant 3. That is where it's negative. Then you say you take whatever is here. Remember, you're gonna rewrite it, negative 3x. You say it's equal to quadrant 2 is going to be 180 degrees minus the reference angle. I'm just writing it like this. I know you are going to have space, I just do not have some space. Then here you say 360 degrees times k. On the other side, it will be negative 3x is equals to quadrant 3, it's 180 plus, isn't it? So it will be plus the reference angle. then plus 360 degrees times k. So you have negative 3x being equal to 180 degrees minus the 60 degrees plus 360 degrees times k, right? Then this side you're gonna say negative 3x would be 180 degrees plus the 60 degrees plus 360 degrees times k. So you would have negative 3x being equal to 120 plus. So I always say to cut things short, right, so that you don't really have to do strenuous calculations here. Just look at here, you have negative 3x, right? Just divide by negative 3 throughout. So you divide here by negative 3, you divide here by negative 3. Same thing, right? You don't have to really waste time that much. So therefore x would be equal to 180 minus 60 is 120. Divide by 3, 612 is 40. I don't know, 12. Yeah, I think it should be negative 40 degrees and then minus 120 degrees times k. Then you write or, and then here you're gonna say x is equal to, then this side is still 240 divided by 3. That should be 80. So you have negative 80 degrees minus 120 degrees times k, where k is an element of integers. Then you are done. Hoping they are correct there. So we found the general solution there, good people. I hope that it's clear on how we use, or rather find the general solution. Still, let's say we have the following is our number 3. Let's say you had 2 sine negative beta plus 3 plus 20 degrees, and then you have a minus here, minus 1 is equal to 0. So let's say you had something like this, right? It does look a bit ugly, but the main goal is to make sure that you isolate the ratio. So you isolate, you leave this as it is on the left hand side. So you're going to have negative 2 sine negative beta plus 20 degrees being equal to 1. Then remember, you divide by negative 2 both sides, so that you have sine negative beta plus 20 degrees being equal to negative half. And now that you have this, you have isolated the ratio. Please remember, we don't take the 20 to the other side. No. Leave the angle as it is. Leave whatever is in the brackets as it is. Then now you find the reference angle by saying that the reference angle will be arc sine 1 over 2. Not negative, but positive. So I think you said that gives you 30 degrees. I think I'm using nice values because I'm avoiding that one that is going to have some commas, but we're going to come to it, right? I don't know, is it half? Is it 30 degrees? 0.5. Yeah, it's 30 degrees. Then, good people, now that you have the reference angle, remember you go to the cross. So here you are, you make your cross. Let me make the cross a bit nicer. Yeah. So make your cross there. Then you identify the quadrants, right? In terms of the quadrants, in terms of the quadrants, the sign here is negative, right? Just before we found the reference angle, the number was negative. So where is sine negative? We know that according to Soccer 2, our sign is negative in here and in there. So we are going to say in quadrant 3, right? In quadrant 3, and then in quadrant what? In quadrant 4. So remember, you take this as it is down here, right? So you're going to say negative beta plus 20 degrees is equal to, in quadrant 3, it's 180 degrees plus the reference angle, and then plus 360 degrees times k, because I'm dealing with sine. This side, this side you still take negative b plus 20 degrees, but then in quadrant 4 is 360 degrees minus the reference angle, and then plus 360 degrees times k. So you then have minus beta plus 20 degrees being equal to 180 degrees plus the reference angle, which is 30 degrees, and then plus 360 degrees times k. Same thing this side, minus beta plus 20 degrees equal to 360 degrees minus 30 degrees plus 360 degrees times k. So how do we solve for beta? I'm gonna try and do it this side on the expanded version. So essentially, in your calculator, what you need to ensure that you do, okay, maybe let's simplify it first. Minus beta is equals to 360 degrees minus 30 degrees. Then I'm gonna take this to that side, so it's gonna be minus 20 degrees, and then you have 360 degrees times k. Then now I'm gonna divide everything by -1. Then everything here would be divided by -1 by -1. So therefore your beta would be 360 minus 30 is 330, minus 20 is 310. So you're gonna have minus 310 degrees and then minus 360 degrees times k. Getting minus today. Yeah. Then on this side you do a similar thing, right? But you're gonna have 180 plus, which is 210, then minus the 20. It's gonna be 190 degrees. So this side you're gonna have your beta as negative 190 degrees minus 360 degrees times k. Right. So then you would have found your general solution there. Great stuff. So let's then move on to this type. Let's move on to this type. G what? G4. So let's say you are given the following. 3 sine theta minus cos theta is equal to 0. Now, do you see now that this one is a bit different from the previous one? Why? Because on the previous you just had one ratio. Even on all the others we did, you had only one ratio, which was sine, either sine or cos. In this case, you have the ratios, both of them here. So what do you do if you have both of the ratios? So that's when you must know that this is type 2, whereby you have sine and cos. So type 2, remember, it's when you have a sine or cos theta plus or minus b, right? That is type 2, this one. So what do? You are going to simply turn that into tan, because let's note that please note that tan theta is sine theta over cos theta. Okay, so due to this identity, we can actually say 3 sine theta would be equal to cos theta. We put them on both sides. Then what do? You simply divide by cos theta both sides. You're always going to divide by cos so that you have sine over cos. If it is otherwise, but in most cases you're always going to divide by cos, so that you have 3 tan theta is equals to 1. So now that you have this, you have isolated the ratio. Now, but you are not done. There is a 3 here, right? So you must isolate it properly and be left with tan theta is equal to 1 over 3. Then you have isolated. Then you are done with the first step. Then now you can find the reference angle by saying the reference angle will be tan inverse of 1 over 3, right? Now tan inverse of 1 over 3 would be 18 comma 434 948. Remember, you must not round off, right? 822 92 degrees. I'm not sure, my calculator usually gives me more values as compared to your calculator. Your calculator already rounds them off. I'm not sure to which number, but just take all the numbers from the calculator and put degrees there. Then you go to the cross. Now on your cross, you identify the quadrants. This number here is positive, right? That number there is positive. So you then say, where is tan positive? Remember that tan is positive in quadrant 1, whereby all of them are positive, and then in quadrant 3 in here. So now you take whatever is here, you write it there. Theta will be equal to the reference angle in quadrant 1 plus 360 degrees times k. So the reference angle is 18,4 what, but it's already there. It's gonna give us the final answer here, so we can round it off to 18,43 degrees plus 360 degrees times k. Right. Yes, there is a question. Yes, ma'am.
Sir, didn't you say that for tan is 180 times k? Papa, it's the same.
Oh yes, thank you so much. I wanted to see whether you would remember that. So that is good. That is good that you actually saw that, good people. So it's tan, right? We use 180 degrees times k. Good stuff. We use 180 degrees times k. Then this side we would say theta. Quadrant 3, remember, is 360 degrees minus the reference angle, and then plus, remember, 180 degrees now times k, because it's tan. So it will be 360 degrees minus that 18,43. Yes, ma'am.
Isn't quadrant 3 180 plus?
Quadrant 3. Oh yes. Yeah, don't worry guys, I'm just testing whether you are focused, né? Right. So quadrant 3 is 180 plus the reference angle, and then you have 180 times k. Okay, good stuff. So those are the things you must actually check out, good people, right? Whether you wrote the correct formula for the quadrant, right? Because that's where the mistakes are. And then you're gonna have 180 degrees plus the 18,434 948 82292 degrees. Then when you add them there, I think it should give you 198,43, and then plus 180 degrees times k. Right, thank you so much for that. Right, that is how we would get it, right? So we make sure that you get tan. If you have sine and cos, try to make sure that you get tan. And sine and cos must have the highest exponent must be 1 and 1. Like they must not have sine squared or cos squared, because once it's like that, it's no longer this one. And that is actually this, but just on this, let's maybe do one more before we go to factorizing. Right, so G5 is it G what? 5. For G5, So you have cos 2x plus sine
Excuse me, sir.
2x. Yes, ma'am.
For example, don't you write k is the element of z?
Yes. K is an element of z. Yeah. I feel like I'm
Sir?
rushing somewhere. Yes, ma'am.
So what does k is an element of z mean?
Okay, so this is because, why are we saying k is an element of z? This is because sometimes instead of saying find the general solution, they're going to say find the angles that satisfy this equation. I think when we do trig functions, everything would make much more sense. But just to give you a perspective, usually we say k is an element of integers, because remember, integers are numbers from negative infinity to positive infinity. They are whole numbers. You must know that negative 1,5 is not an integer. Negative 1 is an integer. So integers are just whole numbers, accounting numbers that include the positives and the negatives, right? So your k, right, when you find the angles, your k would be an element of integers. So it depends on where you want to find the solutions. Usually you would substitute k as negative 3, negative 2, negative 1, 0, 1, 2, 3. Then you would take this formula, you put it here, that's your formula. Then you would substitute, for example, here, so you would say theta, you substitute k as negative 3. If you do that, you're going to have 198,43, right? Plus 180 into negative 3. Then you get negative 3 for 1, negative 3 for 1,57 degrees. Then you would fill out all other angles. So the question is going to give you a restriction to say from this is the domain, then you can be able to get the angles. But when we do trig functions, like I say, it's going to make more sense. By the way, just so that you have a sneak peek, if you can check here, these are actually two functions. You actually have a function of y is equals to 3 sine theta. You have a function of y is equals to cos theta. It's two functions. So if I ask you a question to say find the point of intersection of the two functions, what would you do? Remember, in functions, if you want to find the point of intersection, you equate the two graphs, right? You'd say 3 sine theta is equal to cos theta. In a similar way, say 3 sine theta is equal to cos theta. Then you solve for the theta. So the theta is the one that you would get here. There will be so many of them. Why would it be so many of them? This is because the function would be looking like this, right? For sine. And you can even go to that side. And then the other function would be looking like this. So you can see that they intersect at so many points. So because they intersect at so many points, this gives us all the angles at which they are intersecting. Does it make sense, ma'am?
Yes, sir.
Yes, we are just finding the angles for which the graphs are intersecting. That's why it's called a general solution. It's called general because it's a formula or a solution for all of the angles whereby the graphs are touching each other. But then if you want to find specifically maybe from negative 180 degrees to 180 degrees, then you would pick those angles that are between negative 180 and 180. Good. So very, very good question. Okay, I'm gonna send you another link, right, so that we can continue with this one. Take it so far, right, jot it down, and then try to see if you can be able to get the general solution. I'm going to send you another link now so that we can rejoin. Okay, so now when you have cos 2x plus sine 2x, what I just need you to check before you panic, right? this is not cos squared 2x, right? There is no squared, there is no cubed, there is no 4, there is no 5. It's just cos 2x, and here it's just sine 2x. If you have them in that way, then just remember that you have to get tan. You understand me? Don't panic, don't change, don't like say sine 2x is 2 sine x cos x, what? You're going to confuse yourself. As long as there is no squared and the likes, and you have sine and cos, just make sure that you get tan. So how do you get tan? Tan, remember, is tan theta is sine theta over cos theta. So that will mean that you need to solve it in such a way that you get sine over cos. So if I want to get sine over cos, I will take the cos to the other side. So I'll just leave sine 2x alone. So cos must always be on the right. You understand me? Cos must always be on the right so that you can divide by it. Please, let's remember that. Right? Cos must be on the right, so you simply take that cos to the other side, you divide by it, then you get that here you're gonna have 1, not 0, 1. And then here, sine. Yes, ma'am?
So, I think when you take cos 2x to the right,
becomes negative.
Gonna be negative, yeah.
Yes, becomes negative. Sorry for that. So there is a negative here, and then even here we have a negative. That's good. So we have tan 2x equals to negative 1, right? Then how do we get the general solution, right? Remember, now that you have isolated the ratio, now you can find the reference angle by saying that the reference angle would be arctan 1. Make sure that you are putting a positive number, right? So if you go to your calculator, arctan 1 gives you what?
45.
Gives you 45 degrees. Then you can go to the cross. Remember that where is tan negative? That will be in the second quadrant and the fourth one. So you say quadrant number 2, right? And then quadrant 4. Right. Then remember, take this as it is. So you're gonna have 2x, and then you're gonna have 180 degrees minus the reference angle, and then plus 180 degrees times k. And then for quadrant 4, you'd say 2x is equals to 360 degrees minus the reference angle, and then plus 180 degrees times k. Making sure that you are awake and vigilant to make sure that you have 180 there, since you are dealing with tan. Then now you have 2x being equal to 180 minus 45 as the reference angle, and then you have 180 degrees times k. Then here you're gonna have 360 minus 45, which is the reference angle, plus 180 degrees times k. Then you can divide everything by 2. So that you have your x as being equal to 180 minus 45 to 135. Divide by 2. It's what? 135 divided by 2. You get 67.5. And then here you have 90 degrees times k. You say or x will be 360 plus 45 is 405, and then 405 divided by 2 is 202.5, and then plus 90 degrees times k, whereby your k is an element of integers. And like I said, remember, k allows us to, when we substitute k, we are able to get the angles but it does not mean that, I mean, for this one it means the angles, or rather these values of x, will be where the two graphs intersect. But it does not always mean that the general solution, when you substitute k, you are getting angles where the graphs intersect. Sometimes, especially for those ones we started with, let me just show you real quick. For these ones here, if I'm finding the general solution here, it's not two functions equated to each other in this case. But what is it in this case? It's a function is equal to negative 0,5. So this actually tells you that here it's the y value, and then here is the x value. If you were to look at the graph itself, it means you have the graph of cos, which is going to be looking, it's flipped this one, it's flipped, I restart it this, so it would be like this. So you have the graph of cos, right? And then you have a line which is y is equals to negative 0,5. Here's the line, y is equals to negative 0,5. So you are looking at all the x values whereby this line is going to be touching the graph. So all the x values whereby the line is touching the graph. So in this case, this formula will be for getting these x values here, whereby the y value is going to be negative 0,5. So it does not only mean that it's where two graphs are intersecting, but it's also where a line intersects with the graph. That's why I'm saying when you're doing trig functions, it gets much more understandable. Right. Right, I hope that we are still together. Let me just give you another one that looks, or rather that is talking about that one, so that we understand. Ooh, let me just take my notes here. We need them. We need these notes wherever we go to remind us of what we need to do, right? We need those notes here. Right, so let's have G6. This is one they like the most. Let's say you have 6 cos negative 3 theta, right, is equal to 2 sine negative 3 theta. How do you solve that one? How do you get the general solution, right? You need to be very, very careful. In this case, I put cos on the left on purpose because I know I talked about cos being on the right. It does not mean it should always be on the right. The goal, good people, the goal is to make sure that you are dividing by cos both sides. So meaning that here you must divide by cos both sides so that you have sine over cos. You understand me? That is the main goal, to have sine over cos. Then in this case, what are we going to have? This would cancel that, right? Then you are left with 6 is equal to 2 tan what? Tan negative 3 theta. You see, the goal is to make sure that you have sine over cos because that is tan. Then you divide by 2 both sides. Then you have yourself. Yes, ma'am.
Sir, is it that you see cos negative 3 theta and sine negative 3 theta, are the angles inside always gonna be the same, or will they differ at some point?
The angles must always be the same for you to use this one. Okay, so that is one thing that can also remind you of that type. This is the type we're talking about. We're talking about this type of type 2. So the angles must be the same. The angles must be the same for you to use this type of solving. the angles must be the same. Right, I hope that is clear. Right, so now that we would have this, right, now we have isolated the ratio. Now we can find the reference angle. So you would say the reference angle there would be arctan 3, because here is 3, right? Then arctan 3 would be 71,565. remember not to round off. 051 17708 degrees, right? So now you go to your cross. Then on your cross you identify where is tan positive. Remember that is quadrant number 1, and then that is quadrant number 3, which is in here. So in quadrant 1, remember you're gonna say negative 3 theta is equals to the reference angle plus 180 degrees times k, and then here you'll have 180 degrees plus the reference angle, because in this quadrant 3 is 180 plus, right? Then now plus 180 degrees times k. Okay, then what would you do there? Remember that you can now then substitute, right? You can then substitute the reference angle, and then you would be able to get your solution there, right? So you'd say negative 3 theta is equal to 71,56. There are many, so I'll just say until 08 degrees, and then plus 180 degrees times k, and then here negative 3 theta will be 180 degrees plus 71,5 until 8 degrees. But don't do this, guys. I know that you will have space, right? And time. So then you divide, isn't it? Then you divide by negative 3, you divide by negative 3, you divide by negative 3, negative 3, negative 3, and then negative 3, so that you get your theta there, good people. So I know you can be able to divide there, guys, and then you would be able to get your answers. So you divide by, you get 23, this side you get 23,86 degrees minus, what would be 180 divided by 3? 180 divided by 3 would be 60 degrees times k. Then here you're gonna have your theta as 180 plus arctan of 3, and then you divide by 3. You get the 83, you get divide by negative 3, you get negative 83,86, or even here it's negative 86 degrees minus 60 degrees times k. So you put the word or here, then you say k is an element of the integers, right? Then that will be it then. Then let's go to other types, right? The other types now, like I said, they will be dealing with factorization. So in this case, guys, I'm going to write the steps here so that you remember, but in most cases I'm not going to solve until the last question as an attempt to save time. So what I will do though is that I will always end here when I've isolated the ratio. Then I would like to trust you on the remaining parts, right? And then if there are two, I will show you how to do them. So let's say we have the following. It's best take a question here. So let's say we have 3 sine squared theta minus sine theta is equal to 0. Right, now this one you can see that there is a squared. The moment there is a squared, we can't do like the previous problems we're just doing now. We can't get tan. So what do? You try to see whether you can factorize using the highest common factor, or you can use the trinomial or grouping. In this case, it's two terms. When you have two terms, most of the times it's just going to be the highest common factor. So how do you get the highest common factor? The squared one, maybe it's best to write it as what? As sine theta times sine theta. Then you have minus sine theta is equal to 0. Then when you take out the highest common factor, right, do not stress yourself, just look at the one which is common. Sine theta is common, right? So you do this, you divide by sine theta both sides, and then after that you open brackets, you take the sine theta out. I think I emphasized this when we were doing trig identities, that this is one of the best ways of taking out a common factor, right? Just look at the one that is common, divide by it, multiply by it. Then you're going to have what? Sine theta into 3 sine theta, and then minus 1. Good. Now that you have this, it's more of like you have 3x squared minus x is equals to 0. A question like this, you don't really have to struggle using the general formula, the quadratic formula there. No guys, don't do that. Nah. You can simply just divide by the one that is common. If it's x's, right, for letters, just divide by the same thing with the ratios though, just divide by the one with the lowest exponent. It's x to the power 1. So you divide by x, then you multiply by it, then you're gonna have x into 3x minus 1 is equals to 0. Then you can simply say x must be 0, or 3x minus 1 must be 0. Then you solve. In a similar way, here you simply say sine theta must be 0, or 3 sine theta minus 1 must be equal to 0. You see, so now you're gonna have sine theta is equals to 0, or 3 sine theta is equals to 1. Sine theta is equals to 0, or sine theta is equals to 1 over 3. Good. So you see that you have sine theta is equals to 0 in this. It's like you have two questions on general solution. You're going to do this step for this side and then for that side. So meaning that usually I put a line here so that I separate them. Then I know that for this side, now that since the ratio is isolated, I then say reference angle, right? Then I say arc sine 0. Arc sine 0 is 0 degrees. And in this side, reference angle, I say arc sine 1 over 3. Right? Arc sine 1 over 3. It's gonna be 19,471,220,634,49 degrees. Okay, then remember, after finding the reference angle, where do we go? The cross. So you draw a cross this side, you do the same thing this side, a cross. Then you say where is sine positive? For 0 we say where sine is positive. I know some people will argue that how, but we have negative 0. Good people take the 0 as positive. So where is sine positive? It's quadrant 1 and then quadrant 2. Then you say theta is equals to, right? Theta is equals to. I'd like to trust that you can finish there. And then this side, same thing. Where is sine positive? That will be quadrant 1 and then quadrant 2. Just remember that quadrant 1 is the reference angle plus 360 degrees times k. Just remember that quadrant 2 is 180 degrees minus the reference angle plus 360 degrees times k. Similar thing this side, it's going to be 180 minus the reference angle plus 360 degrees times k. You put the 0 there, reference angle is 0, right? You put 0 degrees there, so it's gonna be 180 minus 0 degrees. This side is just gonna be the reference angle plus 360 degrees times k. So it means it's gonna be 0 degrees plus 360 degrees times k. You put it like that. Okay, then you'll be okay. Next one. Let's say you have cos 2x minus cos x is equals to 0.86 is equal to 0. You find something like this, check. You don't have sine and cos, right? So you cannot say that I'm going to use that one of getting tan, right? And then the angles are also not the same, so you wouldn't win either way. But what can you do? Can I say here actually it's minus 1 here? Okay, maybe let me do it this way. Yeah. So let me say here yeah, let's say minus 1 here. So how you would solve it is that first of all, try to change this to cos. When you have the double angle for cos, try to change it to the one with whatever is here. If you had sine here, you'd change to the one with sine. If you have cos here, you're going to change it to the one with cos. Remember, there are 3 options. It's cos squared x minus sine squared x, or it's 2 cos squared x minus 1, or it's 1 minus 2 sine squared x. If I had sine here, sine x, then I'll change it to this one. Okay, but now that I have cos, I'm gonna change it to the one with cos. So I'm gonna say here I have 2 cos squared x minus 1, and then minus cos x is equal to minus 1. Then what do? This I can take it to the other side, right? So that I have 2 cos squared x minus cos x minus 1, or let me take this to this side. So it's gonna be plus 1 is equal to 0. Then I have 2 cos squared x minus cos x is equal to 0, because these ones give us 0. Then now that it's like this, you can factorize by dividing with the one that is common and then multiplying by it. You divide by cos x, you multiply by cos x. Right. Then what are you going to have? You're going to have cos x into 2 cos x. Remember, get it squared. It cancels one of them there. Then you have minus 1 is equal to 0. Then you know the procedure. It's gonna be cos x is equals to 0, or 2 cos x minus 1 is equals to 0. So you find that cos x this side is half. Then now that you have this, just separate them, right? Find the reference angle this side. The reference angle of that is gonna be, of this is going to be 90 degrees, and then the reference angle this side of cos inverse 1, it's 60 degrees, ne? I think it should be 60 degrees here, cos inverse of half, 60 or 30. Let me check. Cos inverse of half, yeah, 60 degrees. Then remember, you go to the cross now. Where is cos positive, right? It's going to be quad 1, and quad 4. Where is cos positive? Same thing, quad 1 and quad 4. You know quad 1 is going to be x, the reference angle, plus 360 degrees times k. Quad 4 is going to be x, 360 minus the reference angle, and then plus 360 degrees times k. Same thing this side. Quad 1, reference angle, plus 360 degrees times k. X is 360 degrees minus the reference angle, plus 360 degrees times k. Then you solve. So that is how you deal with the ones with the highest common factor. And then the other type is for the trinomial. So trinomial, how will they look like? You can have also something like cos 2x minus sine x. Then it says it's equal to let me check. So you have, let me write it here, 2 cos squared x, right, plus cos x is equal to 3. Then you can find, they say find the general solution here. Now when you solve this, this is like this, isn't it? You're gonna have cos x, and then you have minus 3 is equal to 0. Now when you check it, it's 3 terms now. 1, 2, 3. Now because it's 3 terms, that tells you that this one you have to deal with a trinomial. So you have to find the factors. Okay, you have to find the factors. You treat it as if you had 2x squared plus x minus 3. Now the factors here, right, it's going to be 2x and x, positive 3 minus 1. Hey, is it like that? Check. No. Minus 1 plus 3. Yeah, it's gonna be like this. So similarly, you're gonna write 2 cos x plus 3 into cos x minus 1. Then you will say 2 cos x plus 3 should be 0, or cos x minus 1 should be 0. Then you can say you have 2 cos x is equal to negative 3, or cos x is equal to 1. You divide both sides, you will have cos x being equal to negative 3 over 2, or cos x being equal to 1. Now remember, you have isolated. You divide them, right? You have isolated the ratio. Now you can find the reference angle. So you say reference angle will be cos inverse of, remember, put the one that is positive. Same thing here, reference angle would be cos inverse of 1. Here you should get 0 degrees, and then here you just say there will be no solution, because it's going to give you error there. And that is because the range, you can write it to say for cos, you can write it like this: cos x is going to be between 1 and negative 1. So it cannot be negative 3 over 2 is negative 1,5. It's out of the range. That is why you get no solution. And then this side here, you can find the quadrants now. Quadrant 1 and then quadrant 4. Then you will say x would be reference angle.
Sir?
Yes.
Sir, is this one HCF or trinomials?
Oh, this one is trinomial, because it's 3 terms, ne? It's trinomial.
Yes, sir.
360 minus the reference angle plus 360 degrees times k. So you will have x is equals to 0 degrees plus 360 degrees times k. So you simply have x is equals to 360 degrees times k. This side you're gonna have 360 degrees minus 0 degrees plus 360 degrees times k. So you have x is equals to, you can put the word or here, 360 degrees plus 360 degrees times k, where k is an element of integers. So this is the one that is talking about trinomials. You just have to factorize. Let me say that if you know all the tools that we have talked about, you should be okay, because the one that is we actually have covered all of them. If we can actually check, we have covered this. Okay, the one that we have not covered will be the grouping part, whereby you're dealing with 4 terms, and then also compound angles and dealing with special angles. But we can show you how they work, right? In all of them, the main goal is to isolate the ratio. Whatever we're doing it to isolate the ratio. So let me try to show you this one here. Now look at this one here for 7 marks, right? It looks very, very scary, but it's different. Yes, ma'am.
This one that we're doing right now, it's type 4.
Yes, for grouping. This one we are going to group. Why? How do I know that we're going to group? In most cases for grouping, you're going to have 1, 2, 3, 4 terms. But it doesn't mean that, maybe some of them, they could be simplified, then they return to 3 terms or they return to 2 terms. But if they are separated by plus, minus, and then, then you might find that it's grouping, right? You just have to really check it. So how do you check whether it's grouping? You must check whether the first 2 have a common factor and then the last 2 have a common factor. If we check this, they have a common factor there, isn't it? So what can we do? We can actually say, remember, you don't have to think so much hard when you're finding a common factor. But what I'm going to do, right, is that I'm going to rewrite this one here as minus 4 sine x times sine x. Then I say minus 2 sine x. Then what do? There is a common factor here. You simply divide and then multiply by it. So here you're going to simply divide by, in terms of the numbers 6 and 3, when you look at the factors of 6 and the factors of 3, the highest common factor will be 3. And then what is common here is cos on both sides. That's what you're going to divide by. Don't forget to multiply by it. And then this side, what is common? In terms of the factors, -4 and -2, the highest common factor there is going to be -2, right? And then after that, what is common is sine x. So you have to divide both sides by it, and then do not forget to multiply by it. I'm just writing it this way for you to understand, but that's what we're going to have. But if I write it properly, right, it means I'm going to have 3 cos x outside, and then 6 divided by 3 is 2. Cos will cancel cos. I'm left with sine x, and then here it's going to be 1. Then remember the common factor you took, you write it here, minus 2 sine x, and then you say -4 divided by -2, it's going to be positive 2. Sine will cancel sine, then you're left with 1 sine. Then here it's going to be positive 1. Do you see? It's grouping because this and that, they are the same. So what you do is that you take it out, you just write this, that is the same as the other one. Then the ones that are outside, you just put them in one bracket. 3 cos x minus, don't change their sign or anything, take them as they are. Then this is what you have. Then once you are here, oh, where are our stuff? our steps. We need the steps all the time, to remind us. Copy, let's put it here. Right, yeah. So now that we are here, it's two brackets equated to 0. So you simply say the first bracket must be equal to 0, meaning 2 sine x plus 1 must be equal to 0, or the second bracket here must be what? Equal to 0. So that will mean that you have sine x being equal to negative half, or here what do I do? Remember, remember tan theta is what? Is sine over cos. So I'm looking for sine over cos here. Yes, I will take the other one to the other side, because I see that I have sine and cos. I don't have squared, I don't have anything. So it's just that you remember it again. You need tan. So to get tan here, you divide by cos both sides, so that you have 3 is equals to 2 tan x. Then you can divide by 2. Then your tan x will be 3 over 2. Then you know the drill from here, right? Reference angle, cross, solve. Same thing here, reference angle, cross, solve. So you do this and then work on the 2. Right, very easy stuff. Now in terms of those that are going to require you to use compound angles, it's not showing. Let me try it. Right, here we go. 7 marks general solution. Here they give you this one. I know you see 4 terms, I also see 4 terms. So maybe, you never know. Let's try to see how we can work it out. You have to simplify it first to see what's going on. No, this one is still grouping. Do you see that? If I write sine x cos x, right, I say plus sine x, and then I take these to the other side, I'm gonna have minus 3 cos squared x, and then plus 3 cos x. This is still grouping. Do you see that it's exactly the same as the previous one? There is a common factor here. The common factor is sine. There is a common factor here, is 3 and cos. So it's still grouping, good people. So you do need to divide by the common factor, and then don't forget to multiply by it. Same thing here, you still need to divide by the common factor. In terms of the numbers, 3 is common also. Then don't forget to multiply by it. Obviously, you can write whatever I wrote here in a pencil. Then you can write with the pen nicely that you have sine x cos x plus 1. And then you have, there's a minus here, right? And then your number is there. So you can say 3 cos x, and then cos x plus 1. Then you see that this bracket is the same as that. You combine them. Cos x plus 1. The one that is outside, you say sine x minus 3 cos x. Right. Then what happens? You can now equate the two brackets to 0. Equate this to 0. You say or. Equate it to 0. You need tan. You can already see that I'm gonna look for tan here, right? So you're gonna say sine x is equals to 3 cos x. You divide by cos. Divide by cos. You have tan x is equals to 3. We even did it before this one. Then this side you're gonna have cos x equals to minus 1. Then let's remember reference angle by saying cos inverse of 1, positive 1, you're gonna get 0 degrees. Hey, we've been doing this for a long all this time, so they are very much repetitive. So then you open your cross. This side you will say reference angle will be tan inverse of 3, right? Then you know a cross, then you get your answers. So you can see these questions are quite easy. That's why I'm saying you must always get total on general solution. I wanted the one with compound, right? So this is the one I wanted. Now check this one, right? The general solutions, they will always show you this is the type I am. I mean, look at this one. You can already see that it is the type for the compound angles. Why? Because the compound angles themselves, remember, it's cos, sine, sine. Or you can have cos times sine, sine times cos. So this one is cos, sine, sine. So because of that, what do you do? Since it's 4x and then x 4x, you can rewrite it like this: cos 4x times cos x, and then plus sine 4x times sine x is equals to negative 0.7. Remember that this one should be for cos, because cos is very, you remember, so you would say cos, and then you say 4x. It's a lady, right? She changes her mood, so here it's gonna be minus x, right? Then you simply have cos what? 4x minus x is 3x. Ow. You see, it's very, very easy. So now you just say reference angle, arc cos. Remember, you say the positive 0.7. You get your answer. Then you've isolated, you get reference angle. Then cross solve. Nah. Remember, your quadrant is going to be where cos is negative, so it's going to be quadrant 2, then it's going to be quadrant 3. Great stuff. Let me look for, like, maybe if there's one that is a bit complicated. Nah. Let's check. I think, yeah, let's take this one. 6 marks. Can someone are you still there, guys? Maybe who can lead us on this one, on these free 6 marks? Can we go through it? Mr. Adi, are you there?
Yes, sir.
Right. How would we get that?
Sir.
Compound
Sir.
angles.
We say cos x plus 2 sin x is equals to 0. Or 3 sin 2x minus 1 is equals to 0. Nah. Then you go to this one. You take cos to the left hand. You say 2 sin x.
Oh, so I say cos x is equals to negative 2 sin x.
Yes. Yeah.
Okay.
Then you divide by cos x both sides. Then you say 1 is equals to negative 2 tan x. Then tan x is negative 1 over 2. Then you come to this other one. You say 3 sin 2x is equals to 1. Then sin 2x is equals to 1 over 3.
Nice.
Then reference angle. You say ref angle is equals to shift fact tan negative 1 over 2. Then you get the answer. Then you say shift fact sine 1 over 3. Yes, then you continue.
Perfect. Then you will identify the quadrants. Which quadrants will be this one?
it will be in the second and fourth quadrant.
Second and fourth quadrant. And then this one?
Second and first. Second and first quadrant.
Second and first. Nice, easy 6 marks. Okay, let me maybe see if we can have just one last one. Yeah, I think the one we started with, the one we started with, this one that I gave you, I think it was pretty nice. How would we get the general solution there? Right, if you have 3 tan 4x, right? 3 tan 4x is equals to negative 2 cos 4x. Now this immediately doesn't look like any that we dealt with, right? It doesn't look like any that we dealt with, but if we were to say, right, maybe rewrite this tan as sine 4x divided by cos 4x. One mistake I saw students do is to say here, when they change this, they say 3 on top, 3 at the bottom. No guys, it's just 1 3. That's why it's usually advised to use brackets, and then you have negative 2 cos 4x. Right, then what can you do? My motto that I use, if you have a denominator, try to multiply both sides by the denominator here. So you would multiply by cos 4x. Hey, it's gonna be a nice one. Okay, so you're gonna have 3 sine 4x, since this will cancel, and then you have minus 2 cos squared 4x. Right, and then now you can take this to this side, and then you have plus 2 cos squared 4x. Right, now you can see that it's a squared here. It's not that one way, but you can get tan because you have a squared. So what do you do now? If you have a squared, change it to the one with sign, right? Remember this one, it goes back to this identity. Sine squared x plus cos squared x is 1. So if I have cos squared x, it's equal to 1 minus sine squared x. So whichever angle I'm talking about, if it's cos squared 4x, it will be equal to 1 minus sine squared 4x. So it means here I can rewrite it as what?
So,
yeah.
So for every time for those 3 options, cos squared, we always do this one here, 1 minus sine squared x.
Yeah, for the options there, I'm doing the one with 1 minus sine because here I have sine. You see, it's like when I have cos 2x, I change it to the one with sine because I will have sine x somewhere. But it's always guided by what you have. So here you have, great. So in this case, you're gonna have now minus 2, and then minus 2 sine squared 4x. Right, then you can rewrite it as, or even take it to the other side and rewrite it as 2 sine squared 4x, right? And then minus 3 sine 4x, and then plus 2. Then it goes back now to that one that needs you to factorize using a trinomial, because it's like you have 2x squared minus 3x plus 2, right? And it can be solved, it can be factorized this one. Okay, I think you should have 2x and then x. You need, so you're gonna have minus 2, oh, minus 1 minus 2. Yeah, you see.
So
yeah,
so how did you get the plus 2 this side, the left
plus
side,
2.
the right side?
It's minus 2, ne? Here. Oh, I took this to the other side, so it should be minus. Same way this one became minus, isn't it? So it's minus 2. So when you have to factorize that, it means the factors are gonna change. So you are simply going to have you have x. You need to have minus 3. You have minus 2. So you can say minus 2. You're gonna have 2 times negative 2 is negative 4 plus 1. It's gonna give you minus 3. So these would be the new factors. Then once you have the factors, then you know the drill. Let me try to write it here. You will then say 0 is equal to 2, right, sine, right, 4x, and then plus 1 into sine 4x minus 2. So it means you're gonna have 2 sine 4x plus 1 being 0, or sine 4x minus 2 being 0. So your sine 4x will be equal to what? Negative 1 over 2. And then this side, your sine 4x would be equal to 2. So this one, there will be no solution for it, because the maximum for a sine graph that has amplitude of 1 is 2. Then you can solve this side, as you know. Okay.
Sir. So this 3 marks.
No, it's not really 3 marks. I took this from a question that came before it. The first question had said show that this was the only solution, so I only took it on the last part. That's why it says hence. If you can check there, it says hence, and then it says 3 marks. So they wanted you to already just take this one and use it. That's why it says hence, but on the previous it started somewhere else. All right, good people, I can confidently say that with all the tools I've given you, those are enough tools to make sure that you get 100% on general solution on any question that you're going to come up with. Just do not confuse compound angle and grouping. Please, Boiti.
Sir,
yeah.
What about special angles?
Oh, special angles is a combination of what you call, it's a combination of having a compound angle and some special angle like this. Let me show you. If I were to give you, it's something we just did. If I were to give you cos 30 degrees sine x, right, then I say minus sine 30 degrees cos x is equal to 6, right? So what would you do? Oh, not 6, maybe 0.8. This is a compound angle, right? And when you reduce it, it's going to since it's already a compound angle, this one that has 30 degrees, it's a special angle. So that one you'd what is cos 30 can cos 30, I think it should be root 3 over 2, and then you have sine x. Then sine 30, I think should be 1 over 2 cos x. Right. Then now that it's like this, what do you do? Okay, you shouldn't really have this. This is just a problem I came with from my head. It should actually be 0 there. Okay, 0. So that now you could write it like this, and then say it's equal to half cos x, and then you know you need tan because it's sine and cos, right? You need tan, so you divide by cos, then you would have root 3 over 2 tan x is equal to 1 over 2. Then you can divide by that root 3 over 2. You divide by that root 3 over 2. Then you should get that tan x is equal to 1 over root 3. Then you can solve. Okay, so special angle, if it's already expanded like this, that's how you do it. In most cases you'll find it in this way. They'll just write cos 30 degrees minus x maybe is equal to 0. So if you find it like this, but they can't give you like this because it will be very simple, like here. So that's why usually you'll find it in this way. It's already as an already expanded version of a compound angle. All right, but otherwise those are all the tools that you're going to need for all general solution type questions. Trust me, if you apply these, you are going to get all of them correct. Okay, you would get all of them correct. Thank you so much. Best of luck.